It literally just started thundering, so I have no idea if this video is going to pick up the thunder, but if you hear something in the background, that might be what it is. This is the third installment of the number line modeling, and in this video, I want to go through a way of teaching subtraction that uses the number line as a visualization for what we're doing in the subtraction. Now, the end game for this, why use a number line to do this? So I guess that's the argument that I am making. First of all, we can use a number line to teach a subtraction strategy called constant difference. So this is a way of subtracting. In this case, I'm going to model it on 2-digit numbers, but you could kind of figure out how this might work for other cases. Now, this is a departure from the traditional algorithm that encourages students to reason and develop more flexible thinking than that algorithm. And I put the quotes around the word traditional because what is traditional for one person is not necessarily what's used around the world or throughout history. So when I'm using traditional algorithm, what I am referring to is a method of subtraction that has been taught in American schools for a while. Okay, and it's the method of subtracting that most of the people watching this video probably grew up with, but also not everybody. And it's going to be a departure from that. And this is how the smart kids do math in their head. So if you've ever wondered, like, how did that person do that in their head? And you're thinking that they went through that traditional algorithm in their head. Probably they didn't. They did not do the problem in their head using the algorithm and trying to picture the algorithm in their heads. I know when I was in high school, I thought that for a while, that people that could multiply in their heads, that what they were doing was trying to work through the algorithm in their heads, and they're not. They're looking at numbers in a different way, and that's what this number line strategy does. Now, for this, I want to kind of go through why is the traditional algorithm flawed. So I'm going to go ahead and do this problem out using the method that most people were probably taught. So most of us in our American education, we're taught to begin by looking at the ones digit, and we would say, like, 2 take away 8. Oh, we can't do that. You can't have 2 and take away 8. And so then we go through this process of borrowing where we go to the 7 and we cross that out. We make that a 6, and then we add a little 1 right there, and we turn that 2 into a 12. And now we can do 12 minus 8, and that we're okay with. So 12 minus 8 is 4, and then we move over to the tens digit, and now instead of a 7, we have a 6. So we would say 6 minus 3 is 3, and we would arrive at the answer 34. So the flaws with this is not in that it doesn't work. And so when I kind of get on about like algorithms, it's not because the algorithms don't work, and they do work. But here are some of the issues. First of all, this starts us out with the least important part of the problem. If you were, say, dealing with money in your bank account, okay, you probably would not go through that process. What you would do is something more like this. You would say, well, I have about $70 in my bank account, and I'm going to subtract about 40 away. So I have about 30. And then you might reason to yourself, well, I had a little bit more than 70 and a little bit less than 40. So it's going to be a little more than $30 in my bank account. Okay, and that would be practical for like whatever you're doing. You're estimating something in your bank account. But what I want to point out is that the important part of the problem is the 7 and the 4. It's the tens digit. It's not the ones digit. The ones digit isn't like the important part of the number. The important part is that we're around 30. Like that's the important part. So when we're using a traditional algorithm, we're actually kind of encouraging students to look at the insignificant part like first, and we're giving that like the priority part. Okay, so it's like a little bit backwards there. It involves a borrowing procedure that many or even most students do not understand. And in fact, I would hazard that a lot of adults don't understand what's happening there. Why are we canceling this out and lowering it by 1 and adding a 1? Like, what's going on there? Now, some people might be able to figure out that that 7 is in the tens place, and so it represents a 70. And what we did there was we essentially broke the 70 up into a 60 and a 10 is what we're doing there. So we're leveraging place value, but a lot of people don't see that that's what's happening. They might not have been taught that in school, or like it left their brains. Okay. And what we want to avoid doing in math classes is teaching students procedures that they don't understand. They don't know why that works. It's not that it doesn't work. It does. It gets us to the right answer. But whenever we start getting into areas where we're memorizing steps but not understanding why those steps work, that is what sets up this kind of house of cards. And for some students, they're able to work with that through that. If you were pretty good at math class, then this didn't bother you, or you figured it out on your own. You kind of figured out what was happening when we did that. But for a lot of students, it really does leave them behind, and it starts to build this like house of cards that eventually crumbles when they get to algebra or they get to geometry and so forth. And so we don't want to do that. And lastly, it reduces subtraction to numbers less than 20. So when you're doing subtraction this way, you never really need to deal with a number greater than like 19 in your subtraction, depending on what you're subtracting there. And so it reduces everything down, and students never really work with larger numbers, and we kind of lose this sense of how big numbers are. So again, the flaws with the traditional algorithm is not that they don't work. It's just that they kind of set up a way of thinking about subtraction that is not the healthiest for a lot of students. So how else could we do this? There's actually two ways you can picture this on the number line. And for this purpose, we're going to do it one particular way, but I do want to show you both ways because this is a lesson on number line. So 72 minus 38. One of the ways you could do that is starting at the 72 and then move 38 to the left on the number line, which is how I addressed it in a previous video when I was modeling subtraction on the number line. And here's how you would do this, okay, is you might start with subtracting 2. Okay, and that brings you to the friendlier number of 70. And now that you're down at 70, maybe you go ahead and you subtract 30, and that brings you down to 40. And then you're like, okay, well, I've subtracted 30 and I've subtracted 2. What do I have left? I've got 6 left, and that's going to land you at that 34. Okay, and you would actually do the subtraction in stages, kind of weaving your way towards numbers that you like better. So you could also do that by doing like 72 minus 30 and then subtracting 8, or you could do like 72 minus 30 brings you down to like 42 and then subtract the 2 and the 6. So there's like more than one way to do that. An advantage to that one is that you're seeing what that subtraction is, you're dealing with the full magnitude of the numbers, and you're also breaking that 38 down into smaller pieces, which is just a useful thing for students to be able to do, to kind of deconstruct numbers. Now, the other way you can do this, and this is the way we're going to explore in this video, is you mark off the 38 and the 72, and you basically want to find the difference between 38 and 72. So again, you're already seeing that the number line allows for flexibility and different ways of picturing what subtraction is. Now, in this case, we're going to kind of leapfrog our way up to the 72 and then add up how many leapfrogs we need to make. So one way to do this might be like this. We're going to add 2 to get to, again, like a friendly number. And then we might add 30 And that's going to bring us up to 70. And then we see, oh, like that's where I am. I'm going to add 2 more. That's going to bring me to the 72. And then we figure out, okay, how much did I leapfrog up? And 2 plus 30 plus 2 is 34. And that is the other way to picture it. So I really like that. I personally was taught on that traditional algorithm, and now that I've seen other ways of picturing it, I just think it's so much richer to be able to look at what the subtraction is in different ways, and it's incredibly flexible. So if you think, well, what if you saw this, like once you're able to see this, you can go really, really far with it. So we're actually going to focus on that second way at looking at the difference between the 38 and the 72 as the way to model it for the next slide. So check this out. So here's how the number line would work in teaching. So we would start off with the 72 minus 38, and we already did this one, so I don't want to belabor it, but students could reason their way up, and we go up 30, and then we go up 2, and we add those all up, and we get 34. And then we move on to the next problem. And this is something called a problem string, where you have a sequence of different problems. And now we're going to do 39, which is going to be a little bit to the right, and 73. And students would use the number line. So we're going to add 1. And then we'll add 30, and now we're going to add 3, and 1 plus 30 plus 3 is, again, 34. Now let's take a look at this one. We've got 71 minus 37. So now we're going to come over here on the number line, and 71 would probably be right about there. And you can like show the number lines one underneath another, just like I'm doing. And now for this one, we would add 3. And again, there's flexibility here as well. And then I'm going to add the 30 to bring me up to 70, and then add 1, and 3 plus 1 is 4. And then last but not least, we have 40, and 74 would be over here. And now this time we're going to add 30, and then add 30, and then add 4 to get 34. And so you can kind of see how the number line is being used here to visualize the subtraction. And we've got like all these related problems. So now the question becomes, which of these was the easiest to do and why? And almost universally, everybody watching this, or if you were doing this in a classroom, you would say, well, that's going to be the 74 minus 40. And the y has to do with the fact that that 0 is friendly to work with, because that kind of takes care of that ones digit for us, and we're free to just do the 7 minus 4 is 30, and then the 4 is there is subtracting the 0, like not a big deal. And so that would be the easiest one because we have a friendly number in there. So essentially what we're teaching students to do here is to slide the difference along the number line to a related problem that they are able to do in their heads. So where a lot of people doing 72 minus 38, remember that was our original problem, would not think to do that in their heads. They just would not think to do it. But 74 minus 40, that one is doable in our heads. At least for most of us, it is. It's certainly easier to do in our heads. And so what we're doing here is we're learning how to slide the number line, or slide along the number line to a convenient subtraction. So on the next slide, I have one problem I'm going to put up there, and pause the video if you need to, but I want you to try to do it in your head and then think, would I have done this in my head using the traditional algorithm? Okay, so this is 51 minus 28, and you can think like, would you normally have done 51 minus 28 in your head? Some people, yes. Like that's going to be different for everybody, but for a lot of people, no, that's not how you would think to do it. So let's go ahead and picture this using the number line. So we have 28, we have 51, and what we can do here is slide this. So I think it would be easier to subtract a 30. So I'm essentially going to slide that up to 30. So that was a slide of 2 to the right. So I'm going to go ahead and slide this up 2 to the right. And so my equivalent problem is 53 minus 30, which is 23. And so 3, yay. And looking at that using the traditional algorithm, we would end up doing that, okay? But the number line is I think a better way to do it. And what it does is it gives students like so much more in their toolbox. It encourages different ways of visualizing what subtraction is, and it is a valuable tool at any level of math. So even if you are teaching higher level math, you can kind of bring this in and continuing to shore up students' repertoire of things that they know. And honestly, a lot of students at the high school level like aren't that great at the traditional algorithm. They're not very good at it. And this can give you just like another way to differentiate and try to meet the needs of a wider array of students in your classroom.